Yo, what's up, everybody? Welcome back. Today we're working on our virtual GPU, and today's topic is implementing an OpenGL 3D rendering pipeline. Hooray, hooray. Okay, so context. We have been writing a GPU. We have integrated it into a QEMU PCI device that can draw stuff to the screen, rasterize triangles, run compiled programs by some definition of compiled. We have an OpenGL driver that we've hooked into Mesa. Mesa goes, what GPU is plugged in? He sees ours and he goes, oh, okay, we'll use our GPU backend for that thing. And so we're slowly working towards getting something that can render, a typical OpenGL app. So we have this example, test app, and we're going to run it not on our GPU right now, but on the existing GPU that is already integrated with QEMU. We're trying to draw this today, okay? So this is a 3D monkey who is pulled out of Blender. And we're trying to showing just the UV map on here. So this is proof that we're drawing triangles in the front, and that we can interpolate these triangles relatively correctly according with their perspective and stuff. But if we run this on our GPU instead of theirs, we see this, nothing, right? And so that is because, well, okay, what is this? This proves that at the very least, our application is not crashing. That is a huge improvement over yesterday. But he's not doing anything because the side that tries to execute the code for this is not implemented correctly. So we are trying to run this program. So he takes in a 4x4 transform, he multiplies some input vertices by that thing, exports that as the position, as then passes the UV coordinates of that thing over to the fragment shader, and then the fragment shader is literally just setting the UV as the red and green channels. If we ask Mesa to tell us what this compiles into, let's see, I think ner debug, you'll print VS and print FS, I guess. We get to see some debug output here, and we get to see what these shaders turn into. So we have all the instructions, take this variable, take this buffer, the uniform of the transform, extract part of it, do this multiplication by x's, y's, and z's, do some f adds, some integer adds, and there's a lot of this stuff that we haven't implemented, right? We've implemented some for sure, but other stuff we haven't. So I think the goal for today is essentially to just try to work through this program. This is the Mesa representation of the program. We convert this into a representation for our GPU. Our representation is just a JSON blob that has almost the exact same input, because we get to choose our GPU instruction set, and our GPU instruction set is a JSON parser. So yeah, we're going to be working through this, trying to figure out how to make sure that this does the right thing. We'll see what happens. So there isn't really much of a plan other than start at each, just see where it's not working and slowly make those things work. So let's start moving. I guess we will rename this section in a bit once we discover what the first thing to work on is. In happy hour today, we implemented a recording system for shader running, which is pretty sick. It means that we should be able to run this one time in the virtual machine and then stash the output for later, which should heavily reduce the testing loop. So let's just make sure everything is in the right state. Let's build our GPU library again. I think we have to update. We did a little bit of some performance testing earlier, which I think I have to undo for this to all work correctly. Half-Life 1 on Sphero GPU line? Probably never. I think that I'm finding that I've kind of explored the parts of this project that I want to explore. And so I don't think we have to drive it all the way to running a full game. I would like to get some 3D rendering working, but we don't have to go all the way. At least Doom, right? I mean, Doom is completely software rendered, right? So what's even the point? Okay, let's make sure that Mesa is compiled with the latest and greatest as well. We'll run the virtual machine, and I think once we compile this, everything should be in the right state for us to do some testing. We have to wait for this thing to finish booting. Okay, give him a sec. He's uploading the latest version of our driver, compiling, running. Okay, and it looks like we are writing some input here. Unimplemented input parser is the error that we're getting. So we should be able to, I guess, if we close this now, I think that if we just go back into libgpu now, we should be able to like run our test. Which was zig out bin replay. We were doing some performance testing that we didn't need. And I think that if we run this now, we should see that unimplemented input parser. We do, sick. So we can start like trying to debug what's going on here. So this is coming from, I guess we can just run this under GDB now, actually. Which is kind of sick. I guess we want to break on panic. Does that not exist? Oh, because it's not asserting. Can we like, I guess we break just on this. Okay, here we go. So what is going on here? What is going on here? We are in our shader. We are trying to extract. Right, okay. So someone uploads the GPU, the user space driver of this thing, implements, uploads a bunch of vertices to the GPU, right? So he says like, yo, here is a bunch of data. Here's a buffer of data. And in here, we might write like, you know, vertex positions as well as like UV. So our data is like X, Y, Z, UV, X, Y, Z, UV, right? These are each for each vertex. We have like X, Y, Z, UV. But the GPU doesn't see this as like numbers. He sees this as like a bunch of like bytes, right? So each of these is going to be 4 bytes long. And in order to extract like the different components of this thing, we say, yo, here is like at this position in the buffer, you are going to see this type of data. And I suspect that what we are seeing here is that we have not implemented the part, like we have not said, oh, if there's a 2-dimensional vector in here, I suspect that we haven't implemented that yet. Why is my fucking index or colors all wrong? Here we go. So I think that we were in extract inputs from buff, and yeah, we have a parser for float, vec3, vec4, but we do not have one for vec2, so we just kind of throw that in here. And this is going to look very similar to the existing stuff, except he is expecting that a vec2 is the size of a vec2. Crazy stuff, I know. And he also needs to say that the thing that we're outputting is a vec2. So we will say that this was fix input parsing, I guess. And let's just run without GDB and just see if we can see a different error now. He's mad because we wrote vec f32 here as well, so this needs to be a vec2. And you could argue that all of these functions look the same and they could be factored out, and I would say you're right. That argument would be correct, but fuck you. Okay, so now we're seeing that we are trying to execute some instructions. We are looping over every instruction of this like program that is supposed to be run on the GPU, right? And we eventually get to some point where something's not implemented. So can we at least log on implemented instruction? And can we like at least write down what instruction we're at so that we can see which one we should execute first? Okay, chillin'. And we see on implemented instruction, integer add. So this is kind of interesting. I didn't realize until last time I played it, but Half-Life 1 also has software rendering option. We're surprising. Oh, that's kind of surprising. That's pretty cool. I guess nowadays, though, your CPUs are way faster when Half-Life 1 came out. So your software renderer now probably blows GPUs of that time out of the water, would be my guess. Oh, but I could be wrong. Okay, so integer add. What's interesting here is we have implemented our like variable storage as like a union of these things, right? We have like, it might be an f32, it might be a vec2, it might be a vec3. Now, what's kind of odd here is that the shader output representation from Mesa doesn't really consider the fact that there are floats and ints. It just stores 32-bit values. and then decides based off of the instruction how it's going to interpret that data. So in reality, us storing an F32 doesn't really make sense as much as storing a 4-byte buffer. And then when we use that thing, we need to determine based off the instruction what we're looking at. So how do we do that? On the Mesa side, I can't remember how we are pushing this data. So where does this like iadd coming from? Can we like source? Let's get in the right environment and let's go look at the Mesa code, because I think somewhere we must do something here. That's crazy work. Somewhere we must do something. I know, it's wild. Okay. So can we look at Sphero DRM WinSys and just look at our shader compilation here? So when we do an integer add, we just say, yo, look at the output, look at these indices here, okay? And where is this add coming from? I would like to maybe run our virtual machine again and just kind of like copy paste the vertex shader out so that we can like reference it later. I'm gonna forget this, so I kind of want to look at. With a print, what's the easiest way to do this? Nerd debugs, it'll print vs print fs test app dev dri card1. All right. So let's look at the vertex shader. And hopefully I can copy paste out of here. Can we just kind of like, here. Can we do like, paste? That looks promising, sick. Okay. Set paste, I think. Or we just do this and then it's fine, there we go. Okay, so this is gonna be vertex ir dot text or something, fuck it. Okay, so where are the inputs to this iadd coming in? They're coming in from register 97 and register 56. Or register is the wrong word, variable 97 and 56, right? So we're doing an integer add of these two things. And so I guess this load constant, we are kind of like passing this thing in as an F32. I guess the answer is that we should be passing in a bucket of bytes and interpreting that as we want. So I think that our variable format needs to change here to be like 32-bit val. I can't start with a 32 here. Variable 32-bit. In here, we're gonna keep a value of like 4 U8s. Okay? And then we're gonna have a function as F32, right? And here we're just gonna say like stood mem at to value, bytes to value. Given a pointer to an array of bytes, returns the value specified by the type. Okay. Yeah. And I think this wants me to give it F32 like this, and I think we need to use this as a slice. Yeah. So I think this will do what I want. And it means like when we push that constant, we have like an API that's like push float. Oh, so it's the load constant that we need to fix here. Load constant's F32. This should just become load constant 32. And instead of passing in a float val, I want to pass in like a buffer almost. Right? I almost want to do this. We can get to the other guys later. The like vectors, they're gonna have the same problem. You're overcomplicating this a little bit. I would recommend storing this as U32 because then you only have to deal with endiness at one place max. Then you can just bitcast F32 I32 is needed. Yeah, I'll agree with that. I think you're right. Thank you. So we need to change the implementation of load constant here to be load constant 32. He's going to take in a U32 here. U32 here. Yeah, I guess we could even just do like, we don't even have to do this variable 32 then, I guess. We could just store it as a U32 here. Fuck it. I guess I kind of want this to be like, I don't really want to write U here. I guess it's fine. I guess it's fine. Yeah, fuck it. Fuck it. And this is gonna break all sorts of shit. I guess we forgot that this needs to say U32 as well. And then we have a bunch of places that use it as an F32. So shader C bindings. Can we look for like dot F32? So we want to call this U32 now, I guess. U32 here as well. U32 here. And I guess that kind of indicates that this needs to say 32. And this needs to say 32. And this needs to say 32. Okay. Then that means that the header file kind of needs to correct these to say 32 everywhere as well. Okay. And I don't want U32 here. I just want to say 32. There you go. Okay. He's mad at F32 and shader.zig. So who's using this thing? Okay. So there's a couple F32s in here, so we can say that the input as a float is going to be a bitcast of input U32. I think I still want like an as. I think something about this. I want like a convenience function here. I just don't know where. I guess we could just here. This feels like an okay spot for it. So we can do like self U32 and bitcast this. And then if self is not equal to U32, return error, invalid type. Which means that now we can just go like try input as F32. Nice. And then here we need to bitcast back. Which is a little gross. So maybe we do it kind of like this. And then we bitcast the output here. That feels okay. Then we can do kind of like this is input as F32. And then this is as F32. And then this is a bitcast. the output. Sure. Then there's stuff in shader.zig 264. This one is also probably a problem. Resolve channel ref returns an F32, so it's going to take a U32 and return bitcast of value, I guess. And then there's another one down here. So extract inputs from buffer. I guess we just do this. There's kind of no difference. I think I saw an F32 here as well. Fuck that. Okay. Now in lib.zig, there's some usages of F32 here. So what's going on here? We're interpolating variables. So we have like 3 input variables and we're interpolating them according to A, B, and C. So for each of these variables, we want to say, okay, we're assuming that these are all the same and that they're all U32. And then if they're U32, we just take this and we say as F32. I think this is capital F. He doesn't like that. It's as lowercase. And then all of these need to be tried. Boom, boom, boom. All right. 295. So we have to do something like this. All right. And are we chilling yet? Not quite. As F32 not marked pub, so we will mark it as public. It's fine by me. Okay. So that compiles, which means now we should be able to implement iadd here. So this thing is going to get the 2 inputs, and he's just going to do something very similar here. So he's going to take these things and he's trying to get them as I32, I guess. And you could argue that this is the same thing. So you could even do this as like as 32. Oh, we're getting crazy in here. Right? Boom, boom, boom. Like this. And this. Wow, look at us go. I guess we'll call this insert here. Boom. And then we write the output back. So this goes a bit cast the output. All right. Invalid type a couple places. So because I need to put an exclamation mark here. That's true. Chillin'. And then I think that since we changed the format of the variable, I think we have to rerun Mesa. So I think we have to we have to get the compiler, like the compiled shader to look like the format that we expect now. So I think we need to do a little bit of builds.sh and upload. He's mad because we changed a bunch of stuff. A bunch of our APIs changed. So it was like push float. This is now push 32 everywhere where we said float. There we go. Your stray white space is much worse than it used to be. Don't worry about it. Don't worry about it. I've never really cared that much. It's just usually I have like linters and auto formatters to handle it for me, and I just don't care right now. Okay, so hopefully. Oh, I guess QEMU has to be recompiled as well. That's annoying. That's annoying for it to write down the right thing. Yeah, otherwise it can't deserialize the inputs. But like, you must have gone to a conscious effort to turn off sig format. Yeah, I hate it when my editor formats for me. That pisses me off to no end. So I usually just like run it manually, but I don't care right now. I guess I should care though, because the stream is people looking at the code. So aesthetics of what is written is probably important. Okay. That's annoying. So we're crashing now for some reason. Oh, but we're crashing in the execution. So at this point, the thing should have already been written. I think. I think that we should have seen before the crash recording to this. Yeah, so we already recorded. We're chilling. So we should be able to now do zig build and run the replay. And he's mad at an unimplemented thing. But I think that that unimplemented thing will no longer be the iadd instruction. That would be my guess. Oh, in fact, I don't have to guess because it fucking says it. We fixed this already. We did that. We already intentionally had it write down unimplemented instruction load ubo vec4. So let's fucking go. So we did this at some point that I don't remember. We did a fix iadd instruction, and now we are at load uniform value. Okay, so load ubo vec4. Our guess from yesterday about what this is do I have our test app open somewhere? No. So here we have a uniform value transform. This is a mat4, which is like a 4x4 matrix, right? Our guess here was that a uniform gets converted into a uniform buffer object as part of the compilation. And so the uniform buffer object takes in two parameters. Our suspicion here is that it is the which like chunk of memory was allocated plus its offset in that chunk of memory. That was our guess, right? Do we have the shader output here? It was GPU testing env and then vertex IR, right? So here we see that we have load ubo vec4 with arguments 109 and 98, where 98 is an add of 97 to 56. So 0 plus 0, 0 plus 0 is 0. So 109 also 0. We could argue that these constants could be deduplicated, but whatever. Then we see on the next one that we're doing 111, which is 0, and 101, where 101 is an addition of 58 and 0, right? So you can kind of like infer from like what this is doing is that it has the base offset of the 4x4 matrix, and it's adding in the like index, like a sub offset into that thing, right? That's what this, you could make an assumption that that's what this iadd is doing, and then you could make an assumption that the first argument to this is like a buffer location. That would be my guess, right? So we'll implement it that way, and we will find out later as if it falls over and acts like shit. So I guess that means that our shader needs to have a uniform buffer object, which I'm actually not sure how that gets uploaded. We kind of like made a guess yesterday that the reason that's not crashing is because it just that the calling code treats it like a normal DRM resource, and presumably we've implemented some way to like write to these things, right? When we do like vertex buffer upload, we implemented a command that's like set vertex buffers. No. Where is this? Somewhere we upload vertex buffer. Where the fuck is that? I think in here we have a function somewhere that's like make GPU elms. No. Maybe, yeah, and then here we have like Sphero copy to GPU, right? So this is called here, as well as in buffer subdata. right? So you can say we have like this generic function to take a buffer on the GPU and like put data in it. We could maybe guess that this is being called by the uniform buffer object stuff, but I don't actually know. So I would like to see some sort of proof of that. I would like to see some sort of proof. Buffer obj data. So that's were both of those calls in buffer obj data? Mesa buffer obj subdata. Okay, so maybe my guess here is that this is being called somewhere. Maybe not. Maybe we can look for like Mesa uniforms. So what is like the R call? It's like something like matrix 4x4, right? Something along these lines. So does this actually do the upload? Uniform matrix to storage. Copy uniform matrix to storage. Where does this like go? Flush vertices for uniforms sounds promising here. Not really clear. Not really clear. I guess we could maybe try to breakpoint in somewhere to see what's going on here. So we could, if our guess is that the buffer sub data is being called here, we could maybe just log buffer sub data with offset and size, as well as maybe the handle ID. This should give us a clue, and this is the wrong fucking language. It's probably like this. Is handle a 6432. So this should be fine. And we're not fucking running the virtual machine again. I should just like leave this shit on. Oh, but I can't because it crashes. That's why. Right, I forgot. It crashes as soon as we run it. So hard life for us for sure. But what you gonna do? We could make it so that our shader execution in libgpu only doesn't even try to execute. That would probably make this testing kind of go smoother. But maybe we'll do that next time because we're already here. Okay. So do we see anything interesting here? Fuck. It was buffer subdata. Buffer subdata. So we call this twice. Once with 60 bytes and once with a fuck ton of bytes. Okay. 60's too small for a 4x4 matrix. So maybe that's not it. What would the 60 be? The 60 would be maybe the... I don't know. Unless it's not a 4x4 matrix. I think it is. But maybe it's like clipping some of it off on purpose. It's kind of surprising. Can we look at like what resources are allocated as well? Maybe that will give us a clue here. Fprintf. Allocating resource this number with target this. Okay, so this is going to be... I guess we're going to... It actually makes more sense to do this way. Or I guess down here, actually. This probably makes more sense. allocated resource this, and then we have ret handle here with target of template target. Okay, let's start there. Let's start there. And then let's also fix our libgpu so that he doesn't actually try to run the shader and only tries to compile it or only tries to record it. Right, if we just kind of comment this out real quick. Our GPU should, our like virtual machine should stop crashing on something that doesn't know how to run, which will make testing of this much simpler for us. Much, much, much simpler. Okay. Because then we can just leave this open. Okay, network's up. Run this shit. And then here we presumably will have to kill this thing once it runs a few times. Okay. Oh god. Kill all test app. Ah. Okay. Allocated resource. Okay, so we allocated 1, 2, 1, 2. We allocated 2 resources. It would be easier to test this if to follow this if we put new lines in here. So give it a sec, give it a sec. And can we like not fucking print out all of this trash? I don't care. Okay. So we have 1, 2, and 9. And then we have... Is this the right fucking run? Yeah, it is. So buffer subdata 5 and 6 are none of the things that we have allocations for. Why the fuck is that? Oh, because we return here. Which is a bug. We shouldn't be doing that. That's really bad. Because we forget to do... That's a bug. Because here we're supposed to reference the resource if we make it. So that explains it. We were missing some of the buffers. We'll call it again. And give him a sec. Okay. So 1, 2, 5, 6. Okay. And then we allocate 9 at the end there. So this is target 2, target 5, target 0, target 0. So we have 3 targets in here. 0, 1, 2, 3, 4, 5. This is kind of interesting, but we can maybe assume that one of these things is the depth buffer. One of these things is the rect is probably the depth buffer. 2D is probably the image buffer. And then pipe buffer, the other 2 pipe buffer allocations should be vertex shader and frag, like the vertex data and the uniform. It seems like this does make sense. The fact that it's 60 bytes makes a little less sense, but maybe we just have to live with that. I wonder if this template is supposed to has like initial data that's supposed to go in that thing, and maybe that's why. Maybe he's only substituting some of the data because he knows only some of it has changed. I don't see any like initial data though, so maybe it's fine. My guess here is that that is the thing. So can we look at like buffer sub data? And can we like print this stuff as floats? Interpreted as floats. let's just kind of see what we get. Can we look at like fprintf stood error, the value as a float? It's %f in this language, right? And we can just look at like data I times 4. Maybe do like float like this. I think it's like this. Is how you do this in this language? I think. Okay, let's see what happens when we do that. Wait, did I put a space after the F? I did not, which is important. Because we can maybe like infer a little bit. Oh, fuck. Okay. 1, 2, 3, 4. No, so this is the vertex buffer here. Oh, we've allocated. Sorry, I forgot. So this is a triangle here. I forgot that we've still left in the code to allocate the other vertex buffer. So neither of these are the uniform. Neither of these are the uniform. That's not good. I guess it makes sense. So then we need to somewhere implement some sort of like uniform buffer upload. And I don't really know where that's supposed to go. We have to make that assumption. We did implement set constant buffer where we like added this function. I wonder if this has like the data in there. Pointer to the user buffer if buffer equals null. So maybe we have to actually look at this. Offset to start of data in buffer. How much data can be read in the shader? The actual buffer, so this is where we're trying to go, and then the user buffer must be where the data is. Maybe. We can try looking there and see what happens. I guess this would have made more sense to start here, but you know, what you gonna do? So can we look at like setting constant buffer? So can we look at like who else uses this thing? Like VerGL. He says write this constant buffer with this. How much data can we write in the shader? An over 4 here is a little suspect, but interesting. Let's just start by like writing out what we have. So we have like a size was buffer size. Let's start here. And offset. And what else is in here that we want to look at? We have user buffer. Pointer to user buffer if buffer equals null. So it's not, we can't look at that. We have to look at this. Yeah, so here, this is back to me thinking that like the data is not in here yet. Right? We're gonna see like a handle to the buffer that we're using. But it will not, this shouldn't have the data yet. That's kind of my understanding. We need struct sphero resource star res equal to a cast of struct sphero resource from pipe resource. So this is going to be buffer like this, and then we can look at the res handle here. So this shouldn't work. Okay. Oh, interesting. This is seg faults. Oh. Okay, so if this is null, we must have to do something. So what do? They say, yo, if this thing does not exist, we write a constant buffer. So we probably, this is probably where the upload happens. So do they set in this case? The resource? We have like an index here. So I guess this is kind of like indicating that we are supposed to track the GPU resource associated with this thing. And I guess the optimization here is probably like small chunks of memory can be like embedded directly in commands instead of uploaded independently. Maybe there's like something like that going on. Right, because we can see that in the virgl implementation of this thing, they have like binding UBOs. So binding is their context. No, they have, yeah, their context shader bindings. And they set this like UBOs. They stash this shit. Maybe. No, they're actually only unreferencing something. So they have UBO enabled mask. Yeah, okay. So you could we could maybe assume that this is virgl uploading this data to the GPU and then giving it the index, and then the other side knows to keep track of that probably. So we're just not going to do it that way. What we're going to do is we're going to convert anything to like a GPU resource. I think that's the play. I think that's the play. So we can say like, I want to do something that's like, we keep track we keep track of this in the same way that they did, but I'm going to keep track of them as pipe resources. GPU EBOs. Right? And we can do something that's like, where is this thing implemented? If the buffer let's see. If this is null, we have to like do upload, right? And so we look at like buffer size. For now, I'm going to assert we had like the buffer offset of 0, right? We don't know because we didn't actually get to the point where we logged it. Which makes sense. This is fine. It's fine. So we'll figure something out. So we do like sphero create resource. Where do we like GPU copy to GPU? Okay. So we have alloc GPU obj and copy to GPU. Which I guess means that like this actually doesn't have to be resources here. We can just stash the handle. Maybe we do this. We have the handle and the size. Okay. Then we do like, if we have a UBO there, so we need to take our context. Okay, like this. We have to do like CTX UBOs at index. We have to like check if it's valid. Maybe we just start our handle at -1. And then maybe that kind of allows us to... Yeah, let's do that. So when we create context, here, we do like for CTX BOs whatever the fuck this is. We go boom, boom, boom. This is going to be uint 32 max. Boom. Okay. Okay. Nice. So now we can check if this thing is that. If it's not equal to that, we have to free that thing. Where didn't we delete these somewhere? In like draw VBO, I remember having to free this thing. Oh, it was this DRM close buffer handle. That's what it was. So we need our screen, which comes from PC screen or something. Yep. And then this is going to be whatever handle existed. Okay. Now we replace that thing. Okay. Sure. And I guess like fix me better code would define max VBO unused invalid handle to uint32 max or something so that we can like reference by name, but I'll do that in a second, or I won't. I don't know. Alloc GPU takes in a screen FD as well as a size. Okay. And he needs to take in the handle as well. Okay. This can fail. I guess we just return. And print error. Constant buff obj probably is the name here. Sure. Then we need to copy the data. Right, to do like Sphero, GPU, copy to GPU. Like this, which takes in handle data size. Data. And there's probably something to do with offset. So can we just do like assert buff offset is equal to 0 for now? Because we don't know how to deal with that. I'll just say like, I don't know if maybe we need to preserve the previous data or something. I don't know. Seems likely and possible. Else What is the else here? I don't know. Assert unimplemented set constant buffer for existing pipe resource. Because we don't know what to do there. We do not know. Okay. Let's see what happens if we do this. Okay, I guess we should actually print out what's happening. So can we like... fprintf. I don't know. Maybe we just breakpoint here. GDB args test app dev dri card1. Breakpoint here. This is sphero drm winsys line 618. Yes, run. And let's see what we get. Let's just like take a look at the memory in there and see what it is. Let's take a little peek skis. All right, so we have buff user buffer. We have a 64 byte buffer, which is really good. So if we like dereference this thing as floats and we dereference it 16 times, that looks like a transform. That looks like a perspective transform, right? So we have the X here, Y here, the, hold on, X, 1, 2, 3, 4, 1, 2, 3, 4, the Z component, and then the W component. Maybe. It seems a little strange to me. Maybe this is column order, which would maybe make more sense. So this is the first column, second column, third column. That doesn't really seem right either. Fourth column. Yeah, that doesn't seem right either. I'm not sure. I'm not sure. This 10 in the bottom right is like kind of throwing me for a loop. But I mean, this does, like, at the very least, this does look like something. Maybe that 10 is intentional, I don't remember. Looks like this is the right thing. So we've uploaded this thing to the GPU now, which means that when we execute our shader pipeline, I think we need to do something like this, right? Where we say, use this uniform buffer when you do this thing. Now, obviously, if there were multiple uniforms, then we'd have a problem. But, you know, we don't. Which means that our Linux implementation needs to support this. So there's like something in here where we should take in the UBO handle here. And then in the Linux kernel, in our driver, I guess when we do execute shader pipeline, we should pass in the UBO as well. And it looks like we're kind of doing those as hardware IDs. That's true. Okay, so we have UBO comes like this, and then we pass in the hardware ID for this thing in here. So we've updated 9 and 10 to take in the UBO handle, which means that in QEMU, which we can't edit in this environment, we have to edit in this environment, we need to extract that thing. So we change the texture. This is UBO handle now. We need to go 10 and 11 here. 10 and 12 here for the texture handle, and then pass in the UBO handle here. Okay, which means that in libgpu, we need to take that thing in as well. So that's going to be in like libzig execute graphics pipeline. We said right before the texture, we're taking the UBO. And all of this stuff needs to make it where it's got to go. So here we have UBO is E64. Okay, and then when we get our inputs, we need to look at the UBO here, which I guess is going to be a kind of just like arbitrary byte buffer. We'll say this is also a reference to dumb buffers data, which means that we need to extract that thing. So that's going to come from here. And let's just kind of see where this starts falling over. Does that compile? Okay, that compiles. And then we need to compile Linux as well. Let's make sure we didn't make any mistakes there. Lots of piping, but sometimes you just gotta do it that way. Okay. He's compiling, he's linking. Give him a sec. He's linking again. Didn't we already do? Oh, we did link vmlinux.o, which is different than linking vmlinux, of course. Of course. The next, I don't know why, every time we like reinitialize our environment, the first Linux compiler takes a long time. I don't really understand why. Too many arguments. So I think we didn't update here. This is going to be the UBO here. Oops. Oopsies. Here we go. Okay. Moment of truth. Surely we fucked something up, but it'd be cool if we didn't. It would be cool. Okay. So do our graphics inputs look okay? Oh, fuck. Get me out of here. JQ, UBO, graphics inputs. Might be right. This is like one floating point value. So the length of this thing should be 64 times 4 plus 8. Can I like JQ array length? Is that something I can look at? How to count items. JQ. That's piped into length. Okay. This. Okay, 72. 72 minus 8, 64. 4 times 4 is 16, times 4 is 64. Yeah, okay, I think this is right. Though there's a few there's like some like data that like kind of like spills off the side for reasons I don't really want to go into right now. So this stuff is invalid, but then the rest of this stuff is 64 bytes long, which is the amount of 16 floats. So that's like a pretty good sign that this is right. which is pretty sick. Okay, so now we have the uniform like available to us. And so now the question is what do we do with it? So where is this like shader inputs? Shader inputs. Function execute. Here we go. Okay, so here we should probably pass in the uniform buffer, right? Seems reasonable. Which means that this needs to take in the uniform buffer, which was after format. Okay. Which means that this has to keep going. Which means that here we need UBO like here. And surely this thing needs to keep going. Okay. And then we have that like load uniform. So he's mad because UBO is unused. Okay. And then here he's mad at 56. Where is this used here? Fix me. Pass UBO, but whatever. We don't need it there right now. 235. Wait, what's he pissed about? What the fuck? Oh, I didn't save. That would do it. Okay, so we're at unimplemented load UBO vec4 again. And I think this should be pretty easy. We'll call this LUB, load uniform buffer. And I think we're saying fix me use use buffer ID, but we're not doing, we only have one UBO right now, so I guess we can just assert. We assert this is 0, and we'll just write only have one UBO smile. And then that means that we should be able to go like look at B. So this is going to be times the size of a vector 4, which is going to be 16 bytes. This is the assumption right now. This is the assumption. And so then we're going to be like, this is the start of this thing. End is start plus v4 size. And then we are going to say that like our ID, we're going to put this into an output. So I guess we're like making a vector 4 out of this thing, right? Which is like this. And I guess this is trying to, we have like an array of data, right? From start to end. And we're going to do like some sort of cast here. As bytes as value. Or bytes as slice. Probably bytes as value. And we kind of probably can just cast this to a vec4. I think. I think this will work. I think this works. And can we just like print out this thing? Loaded vec4 of this. Let's just kind of see what fucking happens here. He's mad because we need to bytes to value, I think, instead of as value. I want to copy it out. Okay, and he's hitting unreachable at debug assert. Oh, interesting. What the fuck? I'm surprised. Oh, because this is a reference. Right. So we need to do const a is equal to SSA's get lookup a, or else return error invalid reference. Reference, and we have b is a lookup of b, and then we are asserting that a is equal to 0. So we're going to say a as u32, which doesn't exist yet. It's fine. It's fine. So we assume that this is 0, and then we do, this comes from b as u32. Like this, I think. And I guess we should probably assert that v4 size is equal to, no, that assertion will come out by itself. We do need to return a u32 here. That's a really good point, compiler. Good point. Okay. So loaded vector 4 of this. That's really good. That seems really good to me. That is like the first line of our transform. Now we're getting an error invalid type when we try to cast something to an F32 at line 214. Which makes sense. This makes sense. So our fmul instruction expects that it is multiplying a single F32 by another single F32. But if we look at the vertex shader IR, this fmul that we're doing here for vertex for vector multiplication, it uses the same instruction, which is a little annoying. I don't know how I want to handle this. So if this is taking the thing in 110, which is the vector that we just loaded, and he's multiplying it by 4, by like a duplication of the x value of register 71 here, right? So we could implement this as like its own instruction. We could do like fmul v4. This seems like unique to me. Like this and this seem kind of different. So like this is like a multiplication of like thing by swizzled thing on the right. Right? Which is like, so we could make an instruction that's like mul vec 4 by swizzle. Which I guess is fine. Like it'll just handle this like one unique case, which is like maybe a little bit verbose and a little bit insane. But I'm okay with it. So we can do like fmul by v4 swizzle, who's gonna have a as an index, and then b, he's gonna have, instead of this being one thing, we're gonna do like something like this. So b is 4 channel references. And so now we can take in like anything we want here. Which is a little crazy, but whatever. So this is gonna be like, we're gonna do something like this, where we have like channel reference resolutions from f.b 0, 1, 2, and 3. And this is going to be like const b is equal to an array of these things, right? This is going to be like a vec4 of these, right? Okay. A is going to be this. And then we kind of do this. If a var is not equal to vec4, return error, invalid, invalid type or something. I don't care. Whatever. Okay, then now we can just do output is equal to a times b, and then we can put this thing back in. No bitcast here, it's just output. So we can just do a times b here. I think that's maybe reasonable. Maybe. So now we just have to implement the bindings for this thing. So fmul, we're gonna say command fmul by v4 swizzle. Okay, and this is gonna take in my a, and then he's gonna take in the xyzw references for b. Right, and then all we have to do is go into the zig binding side of this thing, and this is fmul by v4 swizzle. Takes in a, and then we're gonna have to do this stuff. I guess we have the move for. We can kind of copy this from here. Okay. Then we have like 4 things to put in here. So this is, each of these is a channel reference, which has these things inside. So source is equal to AID, index is equal to, or sorry, XID. I guess source here, we don't really know. I'm gonna write variable here for now. I'm pretty sure this is right, yeah. And then we're gonna have the index is XID, and the sub index is X sub ID. All right. Can we just actually like put all this on one line? Nice. So then we just kind of do like YZW and YZW. All right. There's a chance. There's a chance. Alco. Where did I write that? Here. Fix that. Little typo. Here we need to update Mesa now to like distinguish this case, right? So here, when we have like an fmul, we have to like understand the arguments here. So can we look for whoever logs this thing? Probably like, is this a ALU? Okay. Oopsies. Print ALU. Nice. Okay. So how does he extract the like swizzle here? Here. So this is going to look the same as like the move instruction we did before. So it's basically just going to be this. Right? So how does he decide though? How does he decide that the swizzle is used? If this thing has a swizzle, and we look at like the used channels, ner source num components. Okay. So this is still going to be the same, right? But this one's going to be different. Num components here looks likely to be the problem. Okay. Then how do we know? Okay, if this channel is not used, he skips it. Otherwise, he looks at the swizzle output. I see. So here he probably checks if the swizzle at each point is the exact same thing. Right, so the swizzle is going to be used unconditionally. And then we want channel used. So we're looking at the number of source components, which just takes in the num components here. Okay. So we have like ALU def num components. If it was 1, we do what we were doing before, right? And if it's 4, we do something else. Default, we assert unhandled fmul size. And I guess like in reality, we should be doing this on like other things as well, but maybe it's fine. Sorry, apologies for first time chatter, but I don't think I have good advice for you into like how to get into industry. I apologize. I don't think I have a good answer for you, so I'm just gonna skim over that. Sorry. Okay. What was this? It was by vec4 swizzle. Okay. So now we think that the output is going to be one thing. So we should probably like assert that a swizzle is right. So I guess we want to go like 4 int I equals 0, I is less than 4, and increment I. We're basically just trying to make sure that like this at I is equal to I, right? This ensures that the left-hand side of this operation only takes one thing like we is like not swizzled like we expect. Now the other side, however, we can do whatever the fuck we want, which is just like this. So I think that what we are doing here I'm not entirely sure actually. Why? So when we did a move before, this thing was pulling from many sources. But here I expect that it's the same source for all of these. So I think we just do a 1 here. That's my guess. I could be wrong. I'm wrong a lot, but this feels reasonable to me. Swizzle I equals I. So the index of the value, for some reason, I'm failing to process that. It's probably right though. Yeah, sorry. So I think that what we saw in like the ner print is that like if you have a variable, you have like a vec4 a, right? Your swizzle for this thing by default is 0, 1, 2, 3, right? So the first element is the first element, the second element is the second element, the third element is the third element, the fourth element is the fourth element. So in that case, you can kind of refer to this thing as just A. Now, if you have like 1, 0, 2, 3 in B, you have to refer to this as B dot yxzw, right? Because you have to like intentionally flip these two things. So that's why I'm just asserting here that the first argument has the swizzle that is like completely in order. Okay, I think that might be right. I don't fucking know, man. We'll see. Nothing's happening here. I guess maybe because this is breakpointed. Makes sense. Okay, so can we like see what we output? Fuck. Okay. Can we just look for like fmul here? So fmul by v4 swizzle, we have an A of 114 and a B of 71.1, 71.1, 71.1, 71.1, which really matches up with what we expected to see here. Right? When we look at the vertex shader, we have 71 xxxx, 71 1 71 zzz. So I think that we got this right. Right? Because we're seeing what we output is like 71 1, 71 1, 71 1, 71 1. So that looks promising. That looks promising. And like what happens if we try to run this thing? Do we get farther? We are now at invalid type when we are trying to execute something. This is at shaderzig 219. So this is on fmul. So this is still happening, which is surprising. Can we look at like what the fmul on this thing that we upload is? A2B48. It's kind of surprising. So this is coming from vertex output, so we can look at the vertex shader. So we have this one, this one, this one. We only have 3 fmuls in this whole thing, and they're all supposed to be fmul by v4 swizzle. Right? Can we do like a JQ dot graphics inputs. Oh fuck! We have to update we have to recompile QEMU for this to work because the format changed. I forgot because he's the one serializing, so of course it's broken. Have you tried using Vulkan in the past? To Bob, he has. Yes. Well, the answer to that is actually no. I've never used Vulkan. So appreciate the attempt at the answer, but unfortunate that the result was incorrect. Suppose say, hey, what's up? What's up? Okay. So can we run this again? And hopefully this looks a little better. Oh my god, it's so slow. I can't type. Kill all test app. No, kill all space test app. Nice. Okay. So now, can we run this thing? What's he mad at now? Invalid type. Still not looking good. Okay, can we look at, this is probably still in the fmul, right? In shaders.zig. 56. Oops. In 240. Yeah, weird. Oh, this is on iadd. Oh, interesting. Not on fadd. Okay, first of all, these should be eyes. Not that that should make a difference. Can we look at like what's going on here? So we want to break on shader zig 240. First of all, is this happening every time? So no. It's only on the third one? It's kind of surprising. Oh, wait, also. This should be plus. I don't know what the fuck I'm talking about here. Oopsies. I was there. You didn't indeed try to use it. I'm pretty sure I've never tried to use Vulkan. I think I looked at like I've like glanced at the instructions like a hello world and been like that looks too hard. I'm pretty sure I've never written a Vulkan app. but maybe I'm misunderstanding. Okay, so what is A here? Unoptimized out, that's annoying. We have an input here though, where we have, I guess info command is probably what I want. Okay. So we have an iadd here. So payload iadd. There we go. A, B, and output. Okay, so this is 17 by 26. Fuck, this is what I want to. Fuck, stop. Get me out of here. Get me out. No, fuck, get me out. I wanted to open the vertex shader. Fuck. Okay. Okay. So what it was it's 17 by 26. So it's this one. Fadd. Oh, it's in the fadd, not the iadd. Okay. And 17 is in fact a four-dimensional vector. Okay, so we can actually fix this. This is very fixable. Wait. Am I stupid? What's going on here? Why is it trying to execute on inputs? He's at line 240. Which is an iadd. But this is supposed to be an fadd. Did I fuck up compilation? Okay, so this does call push fadd. Did I fuck it on this side? Yeah, I did. Okay, that makes sense. Okay, so we fix this. And then we need to also implement fadd. So we'll kind of get there when we get there. So we recompile our libgpu. And then here we're gonna run build.sh. He's gonna copy the stuff over to the virtual machine. He's going to compile the new version of the thing, which I think that it should be fine. I don't think we added any instructions, so the graphics output should be fine. And so if we run like the replay now, we should now see that he's like, whoa, I can't do an fadd. Yeah, so here he's saying an unimplemented instruction fadd. Nice. Okay. Fadd, that's simple. That is simple. Let's implement that. Fadd. And what are we going to do? We're going to take A and B, of course. And I guess we're going to try to execute an add on this thing. So we're going to switch. I guess we'll do like switch A. I don't know why I'm watching this, but it's really entertaining for some reason, despite me not understanding anything. Let's go! I'll take it, dude. Hopefully there's some value for sure. Well, I shouldn't say for sure. Hopefully there's some value as well, but it's understandable if there's not. So I guess for now, we only have to implement this as vec4. We'll kind of handle the other types later. And I guess we want to take in B as a vec4. And we'll just say that the output is A plus B vec4. And your patience might be rewarded with a monkey. Yeah, it might be. That'd be sick. And this should just be able to go into the output, I think. So we should just be able to be like, yo, this is going to go into the requested output. This will crash if this is not true. So I guess we should probably do like if b is not equal to a vec4, then return error invalid add. We'll say we can't do that at all, and then else we'll just say it's unimplemented. Return error unimplemented. I guess this is an assertion. So we'll say that we have an unimplemented fadd for type tag name of a. Yep. That seems reasonable. And then this else prong that doesn't exist anymore. I don't think I like that error. I don't like that at all. Because like I don't want to have to delete this code just because later, like I know that I'm going to add some more later. I guess like it's reasonable. I mean like being like this is literally unreachable is like a reasonable compiler, but I don't like that it's forcing me to do this. Because like I'm going to have to write that again in the future, and that's annoying. But whatever, it's fine. What's he mad about? You forgot Alec? No. No command ID is at output. Yeah, it is. Okay. So now we are looking at int from float. Integer point part of floating point value is out of bounds in clamp cast. So that means our clamp cast implementation must be wrong. But we made it, it seems like we've like successfully executed the vertex shader. Other vertex shader stuff. And we are now trying to like rasterize the triangles. So we are at like 01, 37, 36, and we'll just say triangle rasterization. What in the fuck is going on here? So in clamp cast, we're supposed to take an F32 and turn it into a U32. And it should always be within the range, right? I don't really see how it's possible that this gets an out of bounds error, right? Because min and max have to be representable as U32s, right? So then if we say, yo, use these things if you have to, then do an int from float on the other thing. Like, how is it possible? How is it possible for this to be out of range? You know? But I guess we can just ask the debugger. Because he's just gonna fucking crash anyways. Like, what the fuck is going on here? This should, like, in my mind, this should be possible. Oh. Okay. Fine. Fucking be like that. Why is this nan? Okay, so stack corruption on abort, probably. Which is a little annoying. So this could be our triangles have somehow ended up with invalid vertices, which I guess is just like a thing that could happen, maybe. I'm a little surprised at where that's coming from. It'd be nice to be able to like trace that nan back, but I guess let's just start by printing out the triangles we're trying to rasterize. How about that? How about that? Triangle. This. Can we just actually print it out as like this? I don't know, man. I think it's a little silly, but you can write else to panic without the log. We have some special cases to allow certain development else prongs, or certain redundant else prongs. Oh, that's interesting. Is there like an isNaN to reduce log spam? I kind of want to see like what we're looking at in general anyways. So yeah, this is fucked up. This is fucked up. So it's likely that we're just doing some dumb shit. Right? That's kind of extremely likely. So it's likely that like the math in our vertex shader is just not applying the way I want it to. So I guess probably we want to go into like shader execution. And if we're seeing infinities and nans, like a division seems like the place, right? So my guess here would be it's on like homogeneous pixel coordinate conversion, because this is where the division would come from. So can we maybe, before we do this, print out our coordinates? Pixel coords or homogeneous genius coords is going to be this. I guess we put a new line here, huh? W equals 0 might cause problems. I think I saw this in your debugger, but that would make a lot of sense for sure. Yeah. So we definitely have zeros in there. And we have a triangle that's just like literally 1 point. So how could this happen? How could this happen? If our perspective... I wonder if this is like right. Surely it's not, right? Surely our perspective transform should not be generating things with W equals 0. But I guess we could kind of special case this for now. And do something that's like, let me return this triangle as an optional, right? We'll say, hey. Or else return null here. Here we'll say if chord 3 is equal to null or equal to 0, fuck this shit, right? That seems pretty reasonable. And then when we take this, we can say or else continue. Now, there's a good chance that this is not correct, but I want to at least see like what other triangles we try to render in this, you know? So can we look at what was output? So, I mean, we can pretty clearly see that we're doing something like dumb as bricks here, right? Every single coordinate has no y or z. Like, we've done something wrong. We've done something wrong. So I would like to maybe, my suspicion here is the fmul here. I want to see what we're doing here. Any times any here. Can we just like A and B? Like, what the fuck am I looking at here? I should probably new line there. Yeah, I mean, it's pretty clearly fucking wrong. Pretty clearly wrong, right? So our load ubo maybe is wrong, right? Because A is supposed to be coming from a loaded ubo. So start is like B as U32 times vec4 size. Okay. Can we look at like the loaded UBO? Okay. Right, it's pretty likely. So we're trying to bisect here if it's that we are loading the wrong thing or we are referencing the wrong thing. And it looks like we are kind of unconditionally loading the same thing, which doesn't seem right. Which makes me think that we might have fucked up our load ubo vec4. We are taking A and B here. Okay. Maybe we JQ our inputs. And I want to look at like the vertex shader. And can we look at like load ubo? So we're taking 115, 107, 113, 104. Okay, can we check if this is right? Okay, so we should be seeing like 113, 104, right? Which we are seeing here. And 104 is supposed to be the output of an addition of 103 and 60. Okay, so let's just see if we ever see a B value of 2 when we call this thing. So loaded UBO with B this. Okay. Let's just see what's going on there. Okay, so we're saying loaded EBO with B equals 0 unconfucking-ditionally, okay? So that's a problem. That we can kind of trace this back. So we know that the UBO value is supposed to come from this instruction, this iadd. So can we say like std debug print iadd output? Output. And maybe we log the inputs as well. Iadd, we're gonna do like this plus this to this. And then we do like insert.a, insert.b. Okay, so we add everything here goes to 0. But like we have a pretty good idea that like 103 plus 60 is probably not supposed to be. Right? If we look at vertex shader 103 plus 60 is supposed to be 2. Right? 60 is supposed to be 2. So why is this not working? Is it... What the fuck have we done wrong? So that means that the resolution of this is wrong? Okay. Which means that the load constant like somehow is not doing what we want. Loading constant this. Loading constant this into this. Okay. So we should be looking at l.val into l.id. Which he's mad at because what? Sure. Let's do this. Okay, can we look for like 62 here? Fuck. Forgot a new line. Okay. So we just look for like into 62. Okay, so there's definitely a bug here for sure, right? Like loading constant 0 into 62 does not seem right in the slightest. Which means that like probably this is wrong. I think that it's because we took the U32 value that is being uploaded and interpret that as a floating point value, which is then getting implicitly cast back to a uint32. So I think we just made a mistake here, and this should be looking at the U32 version of the union. Fucking C, man. Fucking C. Like, does that question mark 000 at least correspond to the first column of the matrix? That would be pure scale. I don't know if that's right. I think it is. No, the first, because our matrix, we are not doing any translation in our transform. We are, and our with a 0 rotation, each vertex should end up with 0, 0, 0, like 1, 0, 0, 0, where 1 is like constant. I'm pretty sure. Okay. Can we kill this thing? Can we run this again now? And is it going to behave differently now? This looks better for sure. Our fmul swizzles now are having like this. Right? This is at least like something. We have unhandled interpolation in triangle rasterization now. So what's going on there? Can we get rid of like this like print spam as well? And then unhandled interpolation. So what's going on here? So if we are interpolating variables, I think that this must be the UV interpolation, right? So we are kind of like providing 3 UV coordinates and interpolating between them to run the fragment shader. Which means that we can probably get this whole thing to output something if we just disable running of the fragment shader. I just want to do something for now where our fragment shader output, can we just use can we just draw the monkey as like a white box for now? Just for a second. I just want to see this thing like fucking, I want to see anything. Unhandled interpolation. Really? Oh, because we're still doing interpolation here, even though, right. Sure, all right. Just let me compile. All right, thank you. Okay, so this ran. Let's see, what the fuck did I just type? Oh my fucking god, dude, let's fucking go. Holy shit. Oh, okay, so clear our triangle rasterization is like a little bit broken, right? We're probably going like out of bounds a little bit. But that's fucking sick. So that means our GPU, like our vertex shader, is executing like almost perfectly. Almost like, yeah, almost perfectly. That's so fucking sick. That's actually sick. So we've loaded a uniform buffer. We've implemented the instructions to like extract components of that vec4 and multiply the inputs. Multiply like each vertex by those things. That's pretty fucking sick. I didn't expect this to work first try. That's like actually like incredibly shocking. Incredibly shocking. That's fucking sick, dude. Okay, let's do UV interpolation. Interpolation like this, and then we should be able to basically just enable all of this code again. I think our fragment shader is like incredibly uh, simple. So I think getting this to work should be really easy. Interpolate vars here just needs to be able to interpolate vec2s, which is just the same thing here, but it's just like as v2, vec2 here instead of as f32. So kind of like this, and then we need to implement as vec2. Do we have textures already? No, no. We'll have to do textures tomorrow. We'll have to do textures tomorrow. I guess we don't even have to do as vec2 here, to be honest. I guess we should. So this is going to be like vec2, and we're going to go if this is just going to be like if we're not a vec2, return invalid type, otherwise return self vec2. Boom. Oops. Mix scalar and vector operands here. That's true. That is true. So do I need to like, if I'm doing a float times a vector in Zig, I guess I probably have to do something that's like this. Maybe like it's like lin vec2. And like this. Okay, and then I fucked up because there's something I made something const earlier, which should be variable here. Come on, baby, let's see it. Okay, unimplemented at resolved channel ref. Oh, interesting. So I think this is probably just another vec2 thing, yeah. Just another vec2 thing. No fucking way, dude. That's awesome. Okay, so color indexing here is wrong, right? This blue should be green. Depth buffer has to be implemented, right? Yeah, there's something else. Oh, you know what? I think that this might actually just be a bug in our PPM render, our like replay output. We might just have we might just have to reverse the output here. It might be output writer write byte. We might want to do like start plus 2. I think it's like this. I think yeah, I'm pretty sure that this is the problem, but we'll have to check in a second by actually running it on the GPU. But for a second, I just want to see what happens if we do this. Yeah, okay, that looks pretty correct, I think, in terms of what we expect to see. So can we hook everything back up so that we can run it directly in the GPU? So execute graphics pipeline. And can we make it so that we do like, if we are trying to record, we record, otherwise we execute, and then we can just do record path is equal to null here. Then everything should just hook itself back up and work. So Zig build, rebuild QEMU. Wait, you have lighting already? Our lighting would be, well, we just baked our lighting into a texture for our sample app. So our sample app isn't doing like Real lighting is just like using a baked texture. So I'm just using UV as colors. Yeah, that's correct. Correct. Okay, so this now should just render something sane. This is going to take like everything is so slow here, which makes it hard to interact with the UI because everything is blocking. So how can we, I guess the trick here is that we try to go into this view off rip and then execute over SSH. And that should make it so we really see something here. And then give him a second because he's fucking cranking out prints that he shouldn't. And why is it taking so long here? And it didn't when we ran over the recording. Oh, because the recording we did a bunch of speed improvements on the recording playback. The entirety of all time here is spent in memory allocation, and we're not using a fast allocator in this implementation. But that's fucking working. So can we just quickly try to get like a rotating demo working? We can fix this. We can fix this for sure. So let's do rotating demo. And for now, what I want to do is I just want to go into build. Are we linking libc right now? No. What's the easiest way to do this? In our C bindings to lib, we can use an arena allocator here. And here, maybe we pass in a custom allocator, which means that here we can pass in an allocator. And then we can just kind of use a better allocator for this. So we can say arena stood heap arena allocator initialized with the GPU allocator. De-init this thing later, and then here we can do like we take the arena allocator, this, and then we pass in alloc here, and then we do an alloc of like 2 megs or 1 meg. And then do a arena reset so that now we're not going to do a bunch of slow allocations within this thing. I think this will work. He's mad because we need to say that we're allocating U8s. And we need to write try here. That's true, but we can't try here, so we have to do catch return. Because this is a C API, return false, just indicate we failed. And then let's go back here and recompile QEMU. And now we shouldn't take like a fucking year to render. We should just take a few days to render, I guess on that time scale. So let's see if that's any better. Root test app dev dri cardplan. Boom. Yeah, that's a lot better. I mean, it's not great, right? Our frame rate's still like absolutely chalked, but it's doing something. Now, can we get rid of like a bunch of the prints in here? That one, that one, that one. Okay. And then hopefully it will run at like a somewhat sane rate. And then what would be cool is if we could get some monkey rotation going on in our test app. We could see like some form of 3D movement, which would be very, very cool. All right. All right, all right, all right. So I think our test app, all we have to do to make this work is do like renderer rotate by some amount around something. So let's just do like an like X rotation, I guess, for now. And I guess we'll do like times delta. And then we'll say const delta is equal to now minus since start, or now since last. I think this rotate is like an amount right now. Yeah, okay, seems reasonable. And now we do now since last. We want this to be like a floating point value. So we want to do like as f32 float from int, boom. And then we probably want this to be like divided by like 1e9 or something. So like we want like maybe like 1 rotation per second or something. So approximately this. I think that's right. Let's run it on the working GPU first. Okay, so that's what we kind of want to see. And I mean, that's fucking sick, guys. That's so fucking sick. Like, obviously, there's some problems here, right? But that's a fucking rotating monkey head. That's fucking awesome. That is so fucking cool. It's actually so sick. Yeah, that's so sick. So I think the only thing that's left here is to implement texturing and depth mapping, like depth buffering. It would be better if the thing was built as release fast, for sure. Yeah, for sure. I guess we can. Fine. You've got me. Zig build. Hold on. We'll fucking do it just for you, Mlog. Zig build. Dash G optimize either release fast. And then we will recompile QEMIT. I'm so prepared for the speed up to be very underwhelming. Yeah, I guess we'll see. I mean, I think that we saw like maybe like a 30% speed up when we did this last time. I can't remember. No, it was a 10x. It was 10x from debug to release, and that was with less shader, like way less shader invocations. Oh yeah, that's way better. That's way better. Hell fucking yeah, dude. Hell yeah. Okay, that's sick. Yeah, thanks for watching, guys. I'm really happy with that. If you like what you saw, we stream most days at around 12:30 to 4 o'clock Pacific time. It is 4 o'clock now. So if you're watching live, you can expect to see us live anytime from like around 3.5 to 4 hours ago and now. If you're new here, there's a YouTube link in the Twitch description where you can check out all of our projects organized by playlist. So we're currently working on like this like GPU testing thing, but there's a lot of other cool stuff in here if you want to check it out. QR code decoder, operating system, like we wrote a debugger. This like ball machine on the right is using like WASM chambers that like users can upload. There's lots of stuff in here if you want to check it out. You might look at these VODs and you might go, wait a second, those are only 2 hours long, right? So there's 12:30 to 2 segment. We call it happy hour. It's kind of like supplemental content where it's like not really like things that are super important for tracking progress, but things that are like kind of hard for me to like YouTube title and thumbnail, or like times where I want to work on something without the stress of trying to get to the finish line at the end of the stream. So if you want to see archives of like that supplemental content, those are kind of the VODs of those are locked behind Patreon and YouTube members. So, but if you want to support me and see that stuff, that is available. If not, it's no biggie. You can follow along just fine with looking at only the free VODs. I think that's all the plugging we usually do. So I think we'll just say goodbye to YouTube. And Twitch, let's find someone to raid.